Ladies and gentlemen, welcome again, and today we'll be looking on combining resistance. And today we'll be looking on how to combine resistance. First of all, there are two methods which can be used to combine resistors. The first method, it will be series combination, and the second method is parallel combination. So let us start with the first method by considering the following circuit. Here we have a cell. This long terminal is a positive terminal, and this one which is short, it is a negative terminal. As we have seen in the previous video, current tends to flow from a positive terminal towards the negative terminal. So the direction of current over here, it will be in this direction. And over here we can measure the voltage due to the presence of this resistor. And let us name it as V1. Also here we can draw some voltages being drawn over here, and let us name it as V2. The same to this resistor. Also here we will have V3, potential difference number 3. So if this is V1, over here it will be resistor 1, resistor 2, and this one is resistor 3. But also a cell over here provides a potential difference. Let us name it as V. In this circuit, all components which are joined in series, always the current is the same. So note that in a series connection, current is always the same. So current passing through resistor 1, resistor 2 will be equal to the current passing through resistor 3. Then through this circuit we will have the equal current, and we name it, we abbreviate it by capital letter I. But the potential difference will vary. Resistor 1 will contain its own potential difference due to its resistance similar to resistor 2 and resistor 3. Then the sum of V1 potential difference at resistor 1, resistor 2, and potential difference at resistor 3 will be equal. Its sum will be equal to the potential difference across the cell or the battery. So V will be equal to, here the voltage or potential difference across this area will be equal to V1 plus V2 plus V3. But from Ohm's law, it has been stated that voltage is equal to current times resistor. Instead of, we'll replace this potential difference with such a formula. So over here we'll have, since the voltage it does not have any subscript or superscript, so it will remain, also its current and resistor will remain the same. So current over here times resistor will be equal to voltage 1. So instead of writing voltage 1, we'll take its current, that is I1, then we'll times with its resistor, which it is also R1. The same applies to V2 and V3. But remember from this note, in series connection, always current is the same. Therefore, I will be equal to I1, will also be equal to I2, will also be equal to I3. Therefore, due to this fact, there is no need of writing I1, I2, I3. All of these will be replaced by capital letter I, symbolizing that showing that they are the same. So if they are the same over here, they will cancel each other. So we will not have all of these, they will not be in our equation. And the last equation will be R equals to R1 plus R2 plus R3. And this is the formula for combining resistors in series combination. Therefore, if we aim at finding the sum of resistors which are in series, the simple way is by taking the sum of their resistance. Also, moving to another part, which is resistors in parallel combination. So considering this circuit, so over here we have three resistors which are in this parallel combination. Let us name this as R1, R2, and this one be as R3, meaning resistor number 3. As we know, in the previous video we discussed about the flow of current. Said that current flows from a positive terminal, which is this one with the long leg. This is the positive, so current will flow in this direction. And another thing that current flows in the opposite direction with charge. So if current flows in this direction, then charge will flow in this direction. So let us continue. Over here, in any parallel combination of components of the circuit, always voltage is the same. Over here we have seen that current is the same, but in this case voltage is the same. So if over here we have current from the source, let us name it, abbreviate it by capital letter I, then if it reaches over here, it will divide like this. And finally, we'll have three different currents passing through these resistors. Over here we'll have current 1, and this one will be current 2, and the last one will be current 3. Therefore, resistor 1 corresponds with current 1, the same to resistor 2 and resistor 3. So if over here voltage is the same, now we'll sum up the current. So the sum of current 1, current 2, and current 3, that is current 1 plus current 2 plus current 3, it will be equal to the current that was before the division or before this parallel arrangement. Then from Ohm's law, Ohm's law, know that voltage is equal to current times resistance. So we'll replace this current over here, current 1, current 2, current 3, and total current by this formula. So in order to insert I in this formula, we ought to make I as the subject of formula. Then current will be equal to voltage over R. So this equation will be replaced in the above equation. Then over here, since this is current 1, and then over here we'll have resistor 1, but voltage it will remain the same. So over here we have voltage over resistor 1 plus voltage over resistor 2 plus voltage over resistance number 3 equals to voltage over total resistance. So since voltage is the same, so they will cancel each other, and the remaining equation will be 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3 equals to 1 over resistance total. So the total resistance in parallel combination or connection will be given by this formula, and this is the simple method of deriving it. Thank you.